Good morning, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to jump right into Unit 10, Lesson 2, trigonometric. These are very important identities. We're going to use these in calculus next year, so this will be an important lesson. The first thing that I want to mention, and because we're going to fill these notes out in our interactive notebook, and we're going to take a picture of the notes after you have filled them out, and we're going to post those as assignments in Google Classroom. And so make sure that at the top of all your notes, put your name. So when you take a picture, we know that they are your notes and they should be in your interactive notebook. And if you don't have your interactive notebook, that's a super sad face. Then just put them on notebook paper and still copy and paste copy them and take a picture and post in Google assignment. So in your notebook is a bit out of order. The second page to Unit 10, Lesson 2, the first page starts off with the sum formulas for cosine. To get to the sum formulas for sine, you have to take your book and flip back a page. If you flip back a page, then you will see this is the actual second page of Unit 10, Lesson 2. And that my student editors, somehow missed this mishap. So just to let you know, the order, this is page 2. You're going to have to go back a page to find that. Alrighty, so let's jump in and talk about these sum formulas, and we're going to start by talking about the sum formulas for cosine. And what the sum formulas tell us is that the cosine, if I add an angle, cosine of A plus B is the cosine of A times the cosine of B minus the sine of A, sine of B. And at this point in your life, you should say, what? I don't get this. I totally don't get this. Where did this come from? How did we develop that? Well, the majority of this video today is I'm going to give you a proof of this one right here, of the cosine of A minus B is equal to the cosine of A, cosine of B plus sine of A, sine of B. So I'm going to give a proof, and I'm going to tell you that this proof is, where'd you go? This proof is, this is a dandy proof, but there are, I trust that you will copy the proof down. You can always pause the video. You're not going to have to recreate this proof. Why we have this proof is that you can say, oh, okay. And we're only going to prove one of the 4 sum formulas. And we're going to choose to prove this one because this is the easiest, most available proof that there is. Okay? So copy this down. We have enough really good students to be able to follow this proof. After we get to this proof, then we'll do some examples of how we're going to use these sum formulas. So the first thing we're going to need for this proof is we're going to have to do a little bit of review. And the first thing we're going to do is review some algebra, and we're going to review the distance formula in algebra. And keep in mind, this is just the Pythagorean theorem. If I have 2 points, x sub 1, y sub 1, x sub 2 comma y sub 2, the distance, the length of that segment in xy land is going to be the change in x's squared plus the change of y squared, all the square root. And keep in mind, ladies and gentlemen, this is just the Pythagorean theorem. Just the Pythagorean theorem, okay? I'm going to be using this distance formula in this proof. The other thing, heavens to Betsy, is I'm going to recall something about congruent triangles. If I have 2 congruent triangles, and I'm going to say these 2 triangles are congruent, and they are congruent because this side is congruent to this side is congruent to this side. They have the included angles between the corresponding congruent sides are also congruent. So these triangles are congruent. You're not going to have to review this as well, but you're not going to have to repeat this. These 2 triangles are congruent because of side, angle, side. Side, angle, side. And if they are congruent, then what do I know? I know that the length B is equal to the length K. That's the result. And this is corresponding parts of congruent triangles are indeed congruent. Okay, so I'm going to need those two particular. I will be using those. Keep in mind, this is the proof that I wanted to do. I want to prove, this is going to be my proof. I want to prove that the cosine of A minus B is equal to the cosine of A cosine of B plus the sine of A sine of B. Here we go. Let's jump into this proof. The first thing I'm going to let this angle right here, excuse me, I'm going to let this angle be, do I want to make that, I'm going to make sure I have my color coordinated right. Okay, I do. So this angle right here, I want this red. This angle is going to be B. Right there. That angle is B. Hard to see that B. This angle right here is going to be A. Okay. This is the angle right here in the middle. That angle is A minus B. Because I go to A and I take away B, that's what the measure of this angle is right here, A minus B. And what I'm going to do is I'm going to come over here to this diagram of the unit circle. And keep in mind, we are on the unit circle, heavens to Betsy. We need to make sure that we are all indeed on the unit circle. We're going to need this later on. But I'm going to, on the right diagram here, I'm going to make it such that this angle right here, I'm going to do it in green, this angle right there is A minus B. True or false? This is a circle. All the radii are equal to 1. So if I just concentrate for a brief moment on this triangle right here, and this triangle right here, I'm going to make this segment true or false. These both are 1. These segments are 1, and this angle is A minus B. Well, compare that with this triangle over here, would you? Well, guess what? Both of these segments are 1, and this angle is A minus B. So what do I know about this blue triangle and this green triangle? They are congruent triangles. So this segment here, let's see here. Let's do this segment in red. That segment there has the same length of that segment because those triangles are congruent because of side angle side. Here we go. So now we're going to go to the next slide, and it's going to show you some points. I have these points labeled. And here's my congruent sides. And my congruent sides are this yellow, this guy, and we're going to use that right there. We know this is A minus B. This is angle A minus B. Well, what is this point, Roy? Well, that point, Woodrow, is cosine of B, sine of B. You betcha. We know that because of unit circle trigonometry. What is that point right there? That point, Woodrow, is cosine of A, sine of A. All righty. Hey, over here, Woodrow, if this angle is A minus B, what's this point? Well, this point's going to be cosine of A minus B, sine of A minus B. So what I'm going to do, and this is going to get a little bit algebra heavy, very analytically heavy, but that's okay. We can do it. So what I'm going to do is I'm going to use the distance formula, and I'm going to find the length, yellow length. This is the yellow length left side. This over here is going to be the yellow length right side. So I recall the distance formula. Change in x's squared plus the change of y squared, the square root. So that is the left side here. And keep in mind, you can probably are going to have to pause the video to catch up with your notes. But this is the change in x's here, squared, of course. change in y's, squared, of course, and the square root. This is the length of the left side with respect to these coordinates right here. Hey, what's the length of the right side? Well, the change in x's this time is going to be cosine of a minus b minus 1. Hello? And then it's going to be the change in y's, which will be the sine of a minus b minus this 0 right here, squared. And here's something that we're going to do here. I'm going to do some algebra. If I have an equation, as I do, I have this equation and this equation. They both are square roots. The first thing I can do, ladies and gentlemen, is I don't need the square roots. Well, the first thing I need to do is go back to that proof. Right there it is. What I don't need, I apologize for that, are the square roots. Because I have the square root of a is equal to the square root of b, that automatically tells me that a is equal to b. So I'm going to eliminate the square roots. And what I'm going to do, and this is where the algebra is going to get intense, I'm going to take and I'm going to multiply cosine of a minus cosine of b times cosine of a, cosine of b. I'm going to square it. So this is going to be cosine of squared a minus 2 of those things multiplied together plus cosine of squared. That's what this is. Cosine of a minus cosine of b squared is equal to that. Next thing I'm going to do is I'm going to square sine of a minus sine of b. What is that equal to? Well, hello neighbor, that's sine squared a minus 2 sine a sine b plus sine squared b. Keep in mind, this is just the left side. Now I'm going to simplify this guy right here. I'm going to add these two things together right here. Oh, and look at this, ladies and gentlemen. I have cosine squared a plus sine squared a. This is a plus sign here, don't forget. Well, what's cosine squared plus sine squared? That's equal to 1. And look what else I have. I have cosine squared b and sine squared of b. What does that equal? That's another plus 1. So I have cosine squared plus sine squared. That's a 1. I have cosine squared plus b squared. That's a 1. That's where this 2 comes from. And then I'm just going to rewrite the negative 2 cosine of a, cosine of b, and the negative 2 sine of a. It doesn't matter. Sine of, I can go sine of a, sine of b. It doesn't matter there. Multiplication is commutative. So this is the left side of the equation here. Keep in mind, we're going to want to see this proof in your notebook. So now I need to deal with this right side. And I'm going to jump down here. Here's the right side. The right side was cosine of a minus b minus 1 squared plus sine of a minus b minus 0 squared. That's a 0. Put that in green so you can see them better. I'm going to square this guy. If I square this, this is going to be cosine squared a minus b minus 2 cosine a minus b. I'm leaving out a couple steps here. I just want you to see the proof here. This is going to be cosine of a minus b times negative 1, and that times negative 1 again. I'm going to have 2 of those guys. Negative 1 times negative 1 is 1. And look at this. What's minus 0? Sine of a minus b, 0 is just 0, plus the sine squared a minus b. This guy is just equal, let's do this in red, is equal to this. And you should immediately, off the page, you should say, oh yeah. Oh yeah, you might, you're gonna have to pause the video. Hey, look, I have this cosine squared a minus b, sine squared a minus b. What does that equal? That equals 1. Hello, neighbor. That's a 1. Put it right there. And I have another 1 here. So 1 plus 1 is 2 minus 2 cosine a minus b. And that's the right side. So now I have the right side simplified. Up here, I had the left side simplified right here. I had the left side simplified. Right side simplified. So I'm going to make them equal. Here's my left side. Here's my right side. This is an equation. Guess what? The first thing I'm going to do, ladies and gentlemen, is subtract 2 from both sides. Nice. I'm going to subtract 2, and then if you look, every one of these terms, the remaining terms, has a factor of -2 right here, factor of -2 right there, factor of -2 right there. These guys are gone. And if I divide every term by -2, what do I have? I have cosine of A, cosine of B, minus sine of A, sine of B is equal to what? Cosine of A, cosine of B. So that is a dandy, dandy little proof. Nobody's going to ask you to repeat it. The reason why we did that is so when we get to using these, applying these formulas right here, and you can go back here, and you can go back and pause the video. You're going to have to get the notes in. Now you will know why, where these come from. And I could do the same thing for this top cosine of A plus B, but this is most accessible to elementary mathematics students, this proof. So what do we want to do now? With the last few minutes on this video, what do we want to do? We want to use these formulas. And the reason why we have these formulas is so that we can find the exact trigonometric values of some other angles besides the nice angles on the unit circle. Okay? So I'm going to use, I want to find the exact value of cosine of 75. And keep in mind, ladies and gentlemen, you absolutely can put that in your calculator, and you can estimate that right away. And hey, go ahead. Absolutely. Estimate that to 4 decimal places. Happy darn New Year. I think it's going to be 9659. But I want the exact value, and I'm going to use the fact that 75 is 40 plus 30. So I'm going to use this guy right here. So I'm going to write the formula down. Cosine of A plus B is equal to the cosine of A, cosine of B, minus sine of A, sine of B. And now I'm going to realize that the cos of 75 is 45. So if I want to find the exact value of 75, cosine of 75, I'm going to realize